Hey guys, welcome back to my series on restoring classic late 40s American black and white electrostatic televisions. In this series I'm going to be pointing out some of the differences between these sets and the more common magnetically deflected sets, give you some tips, some tricks, some suggestions, some pitfalls to avoid to get these up and running. At the end of the previous installment, we got a nice bright raster on the screen, but I have issues with the centering. I can't properly move it up, down, left, right like I should, and the focus control isn't working. So let's take a look at that right now. So these are the two centering controls, and that is the focus control. Now I replaced these resistors, but there's 4 more down in here, one on either side of each of these pots. See, when I showed you guys the resistor divider string and those centering controls, I oversimplified things a little bit. In my diagram, I actually showed the 2 plates connected together and going to the center wiper of a pot. And as at least one of you pointed out, it can't be that simple. No, you're right. The plates don't connect together, and it's a little more complicated with the potentiometers. So let's look at the schematic. Here we go. They're actually tapped potentiometers. So there's a center tap, or not even a center tap, but there's a tap here. I'm not sure if it's in the center or not. And that goes to a 4.7 meg to one deflection plate, and the center wiper 4.7 meg to the other deflection plate. So no, the plates don't connect directly together. They are at different points in that pot. So one deflection plate is at a fixed position within that divider, and the other is variable with respect to it. That's how you can get a slightly different DC bias on each of the plates. One is fixed, one is variable. But these are the 4 resistors, 1, 2, 3, 4, that unfortunately often drift or go bad as well as all these guys, but they're much harder to get at. So what we're going to do, because I also want to show you that board, and I want to check out this focus control, which doesn't seem to be working quite right. And I'm going to take that board out, or at least undo some screws so we can move it and get better access to it without completely disconnecting all the wires. So to do that, we've got, see, at least 1 screw there, and I believe a couple more on the top, and then this whole sub-assembly will come loose and we can bend it up. I may want to disconnect those 2 resistors down there. The rest of it's going to flexible wires that have some lead length, so we should be able to manipulate it a little bit. And unfortunately, these resistors have that black insulating goo on them, so if you got to deal with that, I suggest you do it in a well-ventilated area, because if I hit that joint with a soldering iron, it's going to make a cloud of noxious fumes. Alright, let's loosen up this board. Now, if it seems like I'm spending an inordinate amount of time on the high voltage stuff, there's a reason for that. Because it's what makes these sets so different from the magnetically deflected sets, but it's also some of the trickier stuff to work on, so it's a little bit different from, say, recapping a radio. Once we're done with this stuff, the rest should just be very, very straightforward. So there's 1 screw on this side of the chassis. The other one is on top of the chassis, right about there. These little flat-headed screws with locking washers. Here comes the other one. And yeah, this is loose. Now, these shafts are going right through the chassis, so it doesn't want to come out quite yet. And there's a bunch of wires going through a hole on the top side of the chassis. So, man, but most especially these guys are holding me up. So I'm going to remove one end of each of these resistors are just installed. And then I think we'll have enough slack. These new caps that I tacked in are holding me up too. So, in hindsight, well, I'm glad I tacked these in because I can remove them very easily, but I got to advise you, do this board first before you do this stuff. Because after you, imagine if you'd done a very neat job installing all your new caps, and then you realize you need to get to this, you got to undo that work. I think it'd be easier to do it from this end. Alright. Come on, what am I getting hung up on? It's just a big wad of wires down at the bottom. Alright, there we go. I can do a little cleaning, but that's not the side I really care about. It's the back side. If I pull on these wires, there was slack on the top side. So let me maneuver it a little more easily. There we go. What is, oh, this wire. Alright, I'll do one wire. I might end up replacing it too because it's a little melted. A number of these wires have melted insulation. Probably from previous repairs. I might have done one or two myself. What's a little awkward about these is the wiring job out of the factory is a little sloppy. So this is the main high voltage lead that comes right out of the 6,000 volt supply. The first thing it goes to is these pots. Alright, that's what I was trying to get at. Now we can see. And boy, this is probably factory. Must have been. It's the only time you'd have such easy access to this. What do I mean? I mean the black goo. It's really extensive in around the base of these lugs. Not so much completely coating the resistors, but around where these riveted lugs go through. See, these pots are all pretty filthy. You imagine the high voltage in this area attracts a lot of dust, so if there were smokers, it would attract all that tar, nicotine, and soot, and deposit it all around in this area, so this stuff can get pretty filthy. So let's do a few things. We're going to spray some Deoxida 5 cleaner in there, rotate the pots, undo those resistors, and while I'm down here, I'm going to undo these caps I just tacked in because I left the stump of the old original cap lead. I'll remove those and clean up the lug, and then after I reinstall this board, I'll have a nice clean lug eyelet to insert those caps back into and do a much neater job. For now, they all get disconnected. There we go. 4 shiny new resistors installed with no sharp points. Cleaned up the lugs for the 4 high voltage coupling caps, and I checked the continuity on the wiper and the focus control. It seems to be just fine. So let's reinstall this and hook everything back up and see if it works better now. After reinstalling the potentiometer board, I wired in more neatly all the caps, and I did go with all the white axial. Even though I showed the red VIMA caps earlier, either would work just fine. I also did some work around the vertical output tube. In particular, I replaced the 2 4.7 meg resistors that were sticking up, and some of the associated resistors around were pretty far off in value. Still want to get to this 10 meg in a bit. Right now, let's try firing it up and see if the centering and focus controls work properly now. Now before we get to that, I want to show you the two 4.7 meg resistors I removed from that 6SL7. Remember I was saying again and again, symmetry is important. These values need to be pretty closely matched, as well as the transconductance, the quality of each of the two triodes instead of that 6SL7, because it's all about push-pull. Both the horizontal and vertical, you want equal but opposite clean waveforms. So I can see one of these has been replaced already. Don't know which is the original. I think the one on the left, because it matches style of other resistors I've seen in here. Or maybe when they made it, they had one of one type, one of the other. But more importantly, let's measure them. So ideally, they should be equal. Alright. So let's check one of them. Let's call it 5.7, and the other 6.9. Neither is 4.7, and they're pretty far off from each other. That's why you should replace these. Alright, let's fire this guy up. So we had a few issues last time around. The focus wasn't working, and so we had a few issues last time around. I couldn't center the image very well, and focusing was not working. So let's check out the focus first. Try to zoom in better for you guys. So you can see how there's some striations there. I'm going to focus on those. No pun intended. Alright, so that's a focus control to one extreme. I hope you can see that it is very much out of focus now. And I'm rotating it, and it's getting sharper and sharper. It's pretty darn sharp there, and if I keep going, it gets a little bit blurry again. So yes, this control is now working properly. Excellent. Move it right there. Now, centering. This chassis does have the control function stamped on the chassis. There's a whole row of controls along the back. But you do have to lean back in there to see which is which. So this is horizontal centering, so I should be able to move it left and right with that. Yes, and it's symmetrical. Can move it around the middle. Exactly what I was looking for. I've dimmed the lights. Hopefully you guys get a good clear shot of this. Remember, the set's on its side. To the left is top. So the vertical axis is going horizontally here. Alright, so the focus control is at one extreme right now. That's blurry. We'll rotate it. Good, it's changing. Before it was not. Or at least so little I couldn't tell. So now we're getting much, much sharper. I can see the individual scan lines. If I keep going, it's blurry again. That's what you want. You want to have the sharp focus around the middle. You want to be able to go to either side of it. Alright, now, centering. Now, one nice thing about this chassis is that below all the controls along the back, they stamp the function. Some, they do not, so you really need to get a photo of the back of the cabinet if they're labeled there, or sometimes in the Sam's Photo Fact they show you what they do. This is horizontal centering. Now remember, horizontal is going up, down. Excellent. So I can easily move it left to right, and I can get it so there's a gap on either side. And right about in the middle is where I want it to be. Now what about vertical? Obviously it's up too far this way, which would be the top of the set. So let's try the vertical centering. Not so good. This is all the way to one extreme. The rest just push it up even higher. And I'm not that concerned yet, because the vertical circuits tend to have the worst problems, especially before you do a recap, because they use the larger value caps like 0.1 microfarad, and they're more sensitive to leakage. Now I did replace those two plate resistors so they're more equal now, and I replaced the centering controls. But one possibility is the 6SL7. I tested it and it's good, but I didn't test to see exactly what the transconductance was on each of the two triodes. If one is stronger than the other, that could produce some offset. But I think it's more likely the circuit that's driving this that's going to be a bit wonky. Also, there's one 10 meg resistor grid leak bias that I didn't replace, which could also be affecting this. Now let's go through the rest of the controls. So this is vertical linearity, which should have some effect on the height or these lines, because they're pretty crunched down here and they're stretched up here. It's doing nothing. So I think next what we're going to do is work on the vertical circuitry, because yeah, it seems to be where we have the most problems right now, with at least related to the scanning. So I'm trying to read the rest of the controls. This brightness. Yep, brightness works fine. And then we have it's hard to read. Get some more light over here. Okay, this is vertical size. Okay, so it's scrunched. I can make it bigger. And it gets crazy. But yeah, it does seem to be doing the height. Now back to linearity, because usually height and linearity kind of interact, and linearity does absolutely nothing. It could be a bad control or some other issue. Vertical hold, and not feeding in a signal, so not surprising it didn't do anything. And this is horizontal size. Yep, narrow, wide, excellent. And horizontal hold, again we have no signal coming in, so it's not going to do a whole lot. Alright, so what I want to do next is finish work on that vertical circuit, replace the 10 meg resistor that I have left in there, and replace a couple gaps to get to that. I'll show you that right now. Talking about this circuit right here, I want to replace that resistor and these two caps. Now, I've been focusing mostly on this Admiral chassis. The Motorola TS4, TS18, nearly identical circuit for this, as are most electrostatic sets. The 6SL7 is a really common choice for this, whereas I often use a 6SN7 or 12SN7 for the horizontal. They're in the same family, they're both dual triodes, similar characteristics, but for some particular characteristic they like to use the SL7s for the vertical and SN7s for the horizontal. But there are a few exceptions. National, I think Helicrafters T54, a few of them use identical or nearly identical circuits for both horizontal and vertical. And typically those sets will use, say, a 6SN7 oscillator, then a 6SN7 dual triode for the output. And they'll use this nearly identical circuit for both horizontal and vertical. They just run the horizontal at a higher frequency. But the Motorola and the Admiral in particular use a very clever, very creative circuit for the horizontal. Let's take a brief look at that. So this bottom vertical oscillator, that's very typical to a lot of electrostatic sets. Got a blocking oscillator transformer here, half of it for the oscillator, and then the symmetrical balanced output. But if you check out the horizontal, there's just one tube that does everything. It's the oscillator and symmetrical output. Only using one half, just one triode, does all that. We'll talk about that a bit later when we focus on the horizontal. And I will link you to an article that describes how the circuit works far better than I can, but I'll try to give you a really simplified version of it. That is the product of some very sharp, very clever engineers to do all that with half of a tube, just one triode to do the entire horizontal oscillator and sweep symmetrical sawtooth output. Back to the vertical. Those are those two caps. To get the phase inversion, I do believe that is this stuff. And I did replace, oh no, I didn't replace the .004 yet. So that could also be an issue. That's a tough one to get at. A little bit oddball value. I recommend you use 3900 or 392. Be printed on the cap. That's it's pretty critical, and both the Motorola and Admirals, they're hard to get at. It's poking out down here, this guy. So I'm going to replace that and these two, and that should help us out a lot there. So that's just going to be the output stage. It's that, and that. If we still have issues, we can work our way back to the oscillator. But I think it's much more likely, since we have symmetry problems, that it's going to be in this area. The signal that's feeding into it, the 10 meg bias resistor, I replaced one of them but not the other, so they could be biased differently, which means a lot different gain. Or it's a problem with this RC network here. Alrighty, 10 meg resistor, 0.01 microfarad cap, 0.1 microfarad cap, and the 0.004 that was buried down in there have been replaced. I used a 0.0039 in place of the 0.004. Let's see what, if anything, that did for us. Alright, our vertical is going left to right. Let's try. Size control. Actually, I can already tell things are better because it's centered and we don't have that bright smushed area down at the bottom anymore. I think we got it. So here's vertical centering now. Still kind of favors the top, but I can get it where it needs to be, and it really should be taller than that anyways. Let's get that a little bit taller. Excellent. Linearity control still not doing anything, and I can still tell it's a little mush down here. And until I get a test pattern and a grid and know the linearity is good, I'm not going to worry too much about the centering being off a little bit, because I suspect the centering's off a little bit because it's compressed at the bottom. Alright, so that brings up the next thing. So this is great. We've got a nice stable raster. I can move it around. Let's start working on getting something on the screen. So in the next installment, we are going to put all the rest of the tubes back in and try feeding a signal in. That's it for now. Thanks for watching.